Good morning, good afternoon, good evening, our fellows. Namaste from India. I'm Satya Gupta, Secretary General of ITU APT Foundation of India and Chairman of India IPv6 Council, as well as Chairman of Blue Town India, a technology startup for connecting the unconnected people in rural India. I'm thankful to Professor from Coast to give me this opportunity to make a presentation on frugal 5G, bringing broadband faster to rural areas. It is based on a real life case study of my work in India, where we are using the new technologies to take the broadband to the rural masses. So to start with, I like to start with the 5G requirement, which are the communication requirements of the future. And there are key verticals of 5G ecosystem, the three of well-known vertical: enhanced mobile broadband communication, EMBB, ultra reliable and low latency communication, URLLC, and massive machine to machine communication, MMTC. So these are the main verticals of the vision of 5G as per 3GPP. This may not be needed, especially in rural areas, and that is why in India, where a lot of rural masses are still unconnected to the broadband, we have come out with a new solution, that is what is called frugal 5G. So this is about the various wireless generations: 1G, 2G, 3G, 4G, 5G. And I just want to show from here the comparison between 4G and 5G, because we are in 4G today and we are moving towards 5G. The main comparison points, as can be seen here, are in the peak data rates. Earlier we were talking up to 1 gigabit. Now we are talking beyond 10 gigabit. Same thing has happened to latency. Latency was up to 10 millisecond, and now we are talking of less than 1 millisecond. And then, of course, connection density, frequency, bandwidth consumption. So everything, there is a quantum jump when we move from 4G to 5G. Now let's talk about the rural connectivity. The thinking in 3GPP while working on 5G was to model a high-speed vehicle passing through non-urban areas, driverless vehicles, and critical surgeries by robots. Very futuristic and away from ground reality of rural and remote areas. So what the vision of 3GPP for 5G is basically engrossed in is in solving the future problem of the connectivity and ignoring the immediate problem of especially the rural connectivity. So that is what this picture shows. The rural reality is totally different than the urban situation. Main characteristics of rural broadband connectivity are shown here. The population in small clusters with vast open areas in between, low income and hence low affordability, high capital expenditure, difficult terrains, unreliable grid power availability, and relatively smaller population density. These are the main characteristics of the rural connectivity. And these are bringing challenges, and the main challenges are shown here. One is, of course, the low average revenue per user, ARPU, and that is related to the earning capacity as well as the affordability of the rural users. Then the availability of reliable high-speed backhaul. The high-speed backhaul in urban, it is available. There are fibers everywhere, but in rural the same is not true. and then the unreliable availability of grid power. So these three main challenges are there when we talk of the rural connectivity. So if you want to take care of these challenges and these characteristics of rural connectivity, there is a need for having a rethinking or a fresh thinking on the 5G requirements. So two main things are there: the low cost solutions and limited mobility support. The low-cost solutions basically will come through low device cost, low-cost connectivity, backhaul solution, lower spectrum cost, and maybe a nil spectrum cost. And then there is a limited mobility support. So we don't need the autonomous car here. We don't need a mobility of 200 kmph or more, actually, not the super high speed. What we need in rural areas is basically a primary broadband access which can be fixed nomadic or maybe at a low speed. In addition, we need energy efficient solutions because the grid power is very unreliable. We have to produce the power at site through solar or unconventional means. Hence, we have to use the power very, very scarcely so that the cost of production is also lower. Then large coverage area support. We cannot have multiple cell in one village. So maybe the coverage has to be large so that it reduces capex as well as opex. And we have to make use of the existing telecom infrastructure which may be there for voice, for 2G 3G type of services. Whatever infrastructure is there, that has to be made use of. So it can be towers, it can be some already a power supply, a solar power supply meant for 2G and 3G can be tapped in, and the backhaul what was there for 2G 3G, the same backhaul has to be used or maybe after upgradation. So basically, there are less stringent need-based requirements, which is also called value innovation in today's era. So, and that is how it is leading to what we call frugal 5G, the low cost, low mobility, and large coverage. These three things put together lead to what we call the concept at frugal 5G, usage of affordable middle mile network through IEEE 802.11x based access network, basically based on Wi-Fi or a license exempt spectrum. So this slide shows the basic architecture of frugal 5G and from Indian perspective actually. So what you have is at a Gram Panchayat, and Gram Panchayat is a large village which have a population of up to around 10,000 people. So you have to set up a BSC to serve not only this big village called Gram Panchayat, but also the nearby villages, 2, 3 of them. So the backhaul has to come from there on a conventional mean like optical fiber. In India, there is already a big program of the government called BharatNet, which is bringing fiber to each and every village, and that will work as a backhaul for frugal 5G also. And then you set up a tower there with BSC, and important configuration parameters for that will be cell radius, which have to be quite large, UE height also, there has to be a tower so that line of sight can be achieved. Mobility modeling has to be done, what speed you want, and target edge average cell spectral efficiency. So these are the configuration parameters which are used for designing a system for frugal 5G. So basically, this shows in a architecture kind of thing. So we also call it frugal 5G middle mile network, making use of existing infrastructure, as I mentioned. So there'll be a OFC node or OFC point of presence where optical fiber is terminated, and on that you put a tower with a middle mile access point, and then you can cover 2, 3 villages and the people around that. So the technology used for that has to be unlicensed. Normally, we are using Wi-Fi link, but for the middle mile part, which takes from the tower to a middle mile client, it can be like E band, V band, even white spaces. It can be anything actually. And in some cases, it can be even optical fiber also. So you make use of the existing backhaul which is required for 2G and 3G, and then you extend that backhaul from the optical point of presence to the villages through middle mile, which predominantly will be wireless. It can be on Wi-Fi 6 now in the 5 gigahertz band, or it can be on white space, or it can also be on optical fiber, but aerial maybe. So end users will access the internet through Wi-Fi access points, which will be put in villages also, and all the devices are always Wi-Fi enabled. So, and then these Wi-Fi access points are connected via wireless middle wire network to the nearest OOFC node. So that is how this Frugal 5G will evolve, by making use of whatever existing infrastructure is there. And this is what is showing it in more detail actually. You have to have a point of presence with the optical fiber cable, which is connecting the access point to the internet and to the core or to the cloud basically. So that is there. Once you have reached there, then the wireless takes over actually. So macro BSC is there, middle mile network is there, wireless LAN is there, and somewhere Ethernet link. So whatever is existing thing, they are used in the village clusters, and villagers access the cloud as well as internet through their portable access devices, which are always capable of connecting through Wi-Fi. So the key features of frugal 5G network architecture becomes large coverage area cell to provide ubiquitous connectivity. In India, we have called it LMLC, low mobility, large coverage. So that is a very clear critical requirement of a rural access network. Low mobility, large coverage, small cells, Wi-Fi hotspots as access points for high-speed data connectivity to the end user, and Wi-Fi devices which are very low cost and all pervasive. So they are used at the end device by the end user. Cloud-based architecture is there and going towards virtualization. The control is in the cloud. So they virtualize the control actually. Separate control and data plane, which is there in 5G also. Mirrors the population distribution and is scalable as per the population, because it's a low cost. Access points can be multiplied, and the spectrum also, Wi-Fi spectrum is unlicensed, so you can use and reuse and overuse it actually. So this is how our vision of frugal 5G network meets the rural requirements. So on the left hand side, you have the requirements, and on the right hand side, you have the features in frugal 5G network architecture. So first requirement, as I mentioned, was the affordability. Affordability can be met by low cost WLAN and middle mile nodes, wireless middle mile network, multi-operator sharing also, flexible access control. Then clustered service provision, high-speed wireless connectivity only in clusters. You don't have to cover all the area. So wherever there are population, you cover that. Capable of running on renewable energy. As I told, the grid power is not reliable. So low power middle mile and wireline nodes, because they are low power, so you need to generate very little power, and you need very little storage capacity in your battery, and that makes it low cost. Facilitates local content generation and storage. So cached enabled access element, and that is edge computing. Actually, the content can also be brought on the tower through edge computing, so that local content, and it can be refreshed there, it can be loaded there, it can come preloaded also, and caching also can happen. Then limited mobility support, of course, which is there, and it can be done through wireline backhaul by fixed wireless network. Localized communication, local communication path set up via network functions initiated in fog, that is a network element. Then device segment security also, SDN, using SDN software defined network enables centralized control and deployment of unintelligent nodes in the field, reducing the security risk. So this is what I've taken from our university and our professors who are working on this. Now there is another concept, and that is on the business side, a business model which I call managed hotspot service provider, or hotspot as a service, an innovative approach for broadband access in rural areas. So the combined with these technological innovation, we have also innovated the business model. So for provision of broadband in rural area, a MHSP, the managed hotspot service provider, in partnership with the telco and ISP, installs and maintains a small mast mounted 5 gigahertz Wi-Fi backhaul radio and 2.4 gigahertz access point with solar panel, lithium ion battery, with BTS, all in a box. Actually, everything come in a box and mounted on a mast, and it becomes a tower with BSC. In addition, the MHSP appoints a VLE, and that is the key here, village local entrepreneur from local folks for managing and monetizing the hotspot. There will be a man on ground, but from the local folks only, who will be trained and educated and empowered, funded, so that he can manage it. The VLE is given basic training by the MHSP for regular maintenance and operation of hotspots to provide Wi-Fi based broadband services to the villages. He works as a franchisee of MHSP, act as a single point of contact for all broadband related product, services and application, and takes responsibility of digital literacy, hand-holding, assisted broadband services such as e-governance to the rural masses. In addition, he can also make use of Wi-Fi infrastructure for generating extra revenue through other activities like mobile phone charging, providing railroad ticketing, getting market prices of crops, assisting in doing business transactions, rural e-banking, e-health, getting medical facilities from rural. All these can be value-added services provided by the VLE, who are basically providing the broadband access. So that can be another revenue stream for them. And these are the basically key benefits of this model. MHSP, who is doing the total investment, it creates a sustainable social business in a public private partnership mode. So it is a social business. So it's not just a charity. To make use of existing underutilized infrastructure of telcos, to innovate and deploy out of box solution in a business manner, to add value to stakeholders as well as to society. So that is the MHSP gain. Really, opportunity to become an entrepreneur in your home itself, contributing to the village community for improving the quality of life, in addition to generate employment and livelihood for self and village people, village masses. They get the assisted broadband services at doorstep in their hands, 24 by 7 connectivity to the World Wide Web, content, cloud, improved productivity, efficiency, and lifestyle enhanced. So that these are the benefits. So now my real case study about our project, the Blue Town Wi-Fi initiative. We are working as provider of hotspot as a managed service. So we enable broadband access in rural India, manage Wi-Fi hotspot at Gram Panchayat level and then village level. The customers, our telcos, we give these facility to telcos, ISPs who provide end-to-end connectivity to the end user, local state governments also through long-term revenue share agreement. These are all OPEX-based agreement. Planned infrastructure will be built using license exempt band, that is 2.4, and now 5 gigahertz is also live. So in next 3 years, we have planned to go to 15,000 managed hotspots in rural India. Already we have done about 5,000 of them in the previous 2 years. And this is what this shows it all, whatever I have told. I call it everything on tower, EOT actually. This is our value innovation. So what we do in a village, we find a structure, a mast or a pole or a tower, and if nothing is there, we create a 5 meter structure actually. On that we put everything. I mean the dish to get the backhaul from the nearest optical fiber point of presence from a telco or a government scheme, which may be 2 kilometer, which can be 5 kilometer. It does not matter on in the rural area, and we can use unlicensed band in 5 gigahertz, and in future white space can be used. In future, the free space optic can be used, but even 5 gigahertz microwave, which is unlicensed, can also be. Then you have a omnidirectional antenna, you have filters, you have access point, and you have access point controller, AAA, power unit, battery, content server, which we call local cloud. All are put in a hermetically sealed box IP67, and then you have the solar panel also. So with all these things, you can put everything on the tower and create a access hotspot to cover all of the village, which also have the content, the edge computing, the local content is also there. And this is tailor made for India or for any rural areas actually. So what we have used in our architecture is a principle of 5L. The 5L stands for low cost, low power, low maintenance, local control, and local content, which in turn could scale up to 6.5 lakhs deployment, though we have done about 5,000 already, but the country needs 6.5 lakhs like that by using the modules and equipment locally sourced and manufactured. All these things are locally manufactured actually. So it will complement the government scheme of BharatNet, which is taking fiber to all the villages, and from where we take over actually to provide the middle mile and access, and through last mile hotspot as a managed service. So it has a potential to create 1 million local entrepreneurs. That means 1 million jobs and opportunity for creating more through multiplier effect actually, 3 times of this. And why Wi-Fi? Of course, I think we can even skip this. Wi-Fi has become ubiquitous now. The load of bands are open now, even 5 gigahertz, 690 megahertz spectrum is available free, license exempt. And also you can use it for MDO, fixed mobile convergence. And you can provide 5G type of services by using this unlicensed band, by using IEEE 802.11 AC, Wave 2 802.11 AX, and now Wi-Fi 6 is coming. Wi-Fi 6 is also coming extended. All these things can be used. Wi-Fi actually is becoming a part of 5G ecosystem already through release 16 and 17 of 3GPP IMT standardization process, permitting Wi-Fi to be coexisting with your 5G technologies. And it can be an ideal futuristic platform for IoT, M2M, e-health, e-farming, e-education, e-commerce. So this shows that wherever even voice is not there, 2G, 3G is not there, Wi-Fi can be there as a last mile access. So I called it a broadband dial tone. And in India alone, 43,000 villages are there which don't have a 2G connectivity also. So there Wi-Fi can be the first to go. In addition to broadband, they also bring voice as a OTT over the top. So it is reversing the paradigm actually, because earlier voice used to come first and then broadband used to come or data used to come. So here data will come first and voice will run over that. So that is another thing about Wi-Fi 6 and 6E, because we are talking of 6G here. So Wi-Fi 6 is the Wi-Fi standard version 6, which is working in 5 gigahertz, and 6 is the Wi-Fi standard which will be working in 6 gigahertz, which is getting unlicensed in many countries. At the moment, also 70% of the data traffic reaches the customer or Wi-Fi. And by 2022, 80% of the traffic will be touching Wi-Fi. So Wi-Fi has to become a key enabler of all future connectivity, including 5G. And that is what is shown here. And this is about Wi-Fi and its game-changing role in India, enabling broadband for all. India National Digital Communication Policy, which came 2 years back, has the goal for this year as well as the after 2 years. And they have a goal to have 10 million hotspots actually in next 2 years. Currently, we are only having less than half a million actually. So much growth has to happen, and there are different projects: BharatNet, GramNet, NagarNet, Jan Wi-Fi actually. So many projects are there which are being used. And we also got a international actually appreciation when we went for this, where the FCC chairman, Mr. Ajit Pai, recently quoted, "I commend Prime Minister Modi and Indian government for their ambitious goals of universal internet access by 2022 and fixed broadband access to 50% of households in 2022. To meet these targets, they are pursuing bold strategies such as installing 2 million public Wi-Fi hotspots in rural areas and redesigning and expanding the Universal Service Obligation Fund. And as in case of parts of Assam, Uttarakhand, and Karnataka, that is where I'm working, we have communities in Alaska, Utah, and Kansas that don't have access. So he has really complemented our efforts at that level actually. And that is what our policy says. These are the bands which are unlicensed in India. Of course, they are known to most of you, 690. This is another concept that if you unlicense a band, its spectral efficiency increased 1000x actually. And this is the promising role which I've already explained also, that how these both Wi-Fi and 5G together can lead to frugal 5G. Technology perspective, business case and service deployment, convergence and coexistence, standardization is critical. Luckily, Wi-Fi is also becoming a standardization part of 3GPP through release 16 and 17. Hence, in future, Wi-Fi as well as the 5G technology have to coexist based on the need, based on the development in a particular country and the cost part of it. And that is where the frugal 5G is playing a great role, especially in India, and it can be replicated in the developing countries as well. So with that, I'm really thankful to all of you for a patient listening, and I'll be available if time permits for any question or any information more you need. So thanks a lot, Professor Slim, for this opportunity given. Thank you.